Hello, I'm Vidya, your tutor. Let's learn number systems together, step by step. Welcome. In this chapter, we explore the world of numbers, from the counting numbers you already know, all the way to irrational numbers like root 2. By the end, you'll see how every number finds its own place on the number line. Let's meet the families. Natural numbers are the counting numbers. Add 0, and you get whole numbers. Include negatives, and you get integers. And any number you can write as p over q, where q is not 0, is called a rational number. A rational number is a ratio of two integers, as long as the bottom isn't 0. A beautiful fact: between any two rational numbers, there are infinitely many more. And every rational number has a decimal that either stops or repeats forever. To find a rational number between 1/4 and 1/2, just take their average. 1/4 plus 1/2 is 3/4. Divide by 2 to get 3/8. As a decimal, that's 0.375, which sits neatly between 0.25 and 0.5. Some numbers can never be written as p over q. We call them irrational. Their decimals go on forever with no repeating pattern. Famous examples are the square root of 2, the square root of 3, and pi. Put the rationals and the irrationals together, and you get the real numbers. Here is the key idea of this chapter. Every real number matches exactly one point on the number line, and every point on the line is some real number. You can spot the type of a number from its decimal. If it stops, it's rational. If it goes on forever but repeats, it's still rational. Only when it goes on forever with no repeat is the number irrational. Let's turn a repeating decimal into a fraction. Call the number x. Multiply by 10 so the repeating part lines up. Subtract the original x, and the endless tail cancels, leaving 9x equals 6. So x is 6/9, which simplifies to 2/3. When two digits repeat, multiply by 100 instead. Subtracting cancels the repeating tail again, giving 99x equals 35. So the fraction is 35 over 99. Notice the trick. One repeating digit, multiply by 10. Two digits, by 100. We can even draw root 2. On the number line, mark OA of length 1, then a perpendicular AB of length 1. By Pythagoras, OB squared equals 1 plus 1, so OB is the square root of 2. Swing that length down onto the line with a compass, and you've located root 2 exactly. Real numbers obey friendly rules. Combine two rationals and you stay rational. But add a rational to an irrational, and the result is always irrational. For roots, the product of root A and root B is root A-B, and division works the same way. We usually don't like a square root sitting in the denominator. To clear it, multiply top and bottom by that same root. So 1 over root 2 becomes root 2 over 2. Same value, but much tidier. When the denominator has two terms, multiply by its conjugate, the same expression with the opposite sign. Using the identity a plus b times a minus b equals a squared minus b squared, the bottom becomes 4 minus 3, which is 1. So the answer is simply 2 minus root 3. Finally, the laws of exponents hold for real bases too. To multiply powers, add the indices. A power of a power multiplies them. To divide, subtract. And anything to the power 0 is 1. Let's recap. Real numbers are the rationals plus the irrationals. A decimal that stops or repeats is rational. One that never repeats is irrational. And we rationalize denominators to clear away the roots. Great work! Practice a few problems and these ideas will click. Great work! Keep learning with Vidya and visit CBSETest.com for free lessons, worked examples, and practice tests.